This is lesson 7.5 and 7.6. In this lesson we're going to do a brief recap on how to solve for triangles, and then we're going to do some word problems involving the trig ratios and solving triangles. So before we begin, let's take a look at what information we can use, what tools we have to solve these problems. There's a few different tools. Just to recap though, remember that when we say to solve a triangle, that means basically find all the unknown sides and all the unknown angles. So angles and sides need to be found. And what tools do we have to work with? Well, first of all, we have our trig ratios. We have sine, we have cosine, we have tangent, and usually we can use these trig ratios to find sides and angles. We also have our Pythagorean theorem. And this basically lets us find sides. And then we also have the sum of the interior angles. Interior angles. We know that in a triangle, so I have a triangle, which is equal to 180 degrees. So we can use our knowledge of all these tools here to help solve triangles. If you can solve a basic triangle, then basically when I give you a word problem, you can design a right angle triangle setup and then use all these tools to solve that word problem. But before you do anything, you need to know how to solve a triangle just in that context without any practical applications yet. So we're going to solve triangle ABC. Again, we call this triangle ABC because it has the letters A, B, and C on the vertices. If it had D, E, and F, we'd say triangle DEF. So this is triangle ABC. We want to solve for it. Notice we have we want to find everything that's missing. So we have angle theta over here that we need to find. So let's plan this out. So plan. One, we need to find theta. We need to find, so this side here is missing. So since it's where A, this is vertex A. This side here is the opposite of vertex A, so that would be side little a. So find side little a. We also need to find this missing angle here. We'll call this angle B. Find angle B. We could have called this angle A as well, but here we just decided to use the Greek letter theta. So we can use a variety of different techniques. Let's use our trig ratios if we can to find the different angles. So I'm going to start with finding theta. So part 1, find theta. Let's look how it relates to our side. So I'm just going to put a little note here. So ka toa. We have a few different sides that are known to us. We know this is the hypotenuse all the time because it's opposite of the 90-degree angle. So we have an adjacent and a hypotenuse. So adjacent and hypotenuse is cos. So we know that cos theta is equal to adjacent side over hypotenuse. So that means that cos of theta is equal to 4, which is the adjacent side because it's next to theta, over 10. So we know that the inverse cosine, so theta, is going to be equal to the inverse cosine of 4 over 10, which is going to be, let's take our calculator out, make sure it's in degrees mode first. So we're doing second function cos brackets 4 over 10. You can do divided by 10 or 4, your fraction symbol. Close the bracket, and we get 66.42. I'm going to round the degrees, the angles to the nearest whole number in this case here. So we'll get approximately 66 degrees for theta. So we can go in there and write 66 degrees now. So we have that. We can solve for angle B now because we know the sum of the interior angles of the triangle is 180. So for step 2, we're going to find angle B. Angle B is going to be equal to 180 minus the sum of the other two angles, so 90 plus 66, which is equal to, so we have 90 minus 66, so we get 24 degrees. Now, I just want to show you that you could have done this with trig ratios. It's probably safer to do it with trig ratios. Actually, in this case, yeah, we could do it with trig ratios. Let me just double check to see if we can do that. Yes, we can. It's safer to do it with trig ratios because you have some given information in the question. And so if you made a mistake with 66, then your mistake follows through with angle B as well. So I'm going to show you how to do it with trig ratios. So we're looking at angle B. And how does 4 relate to angle B? Well, 4 is the opposite side of angle B. So we have the opposite and hypotenuse. Opposite and hypotenuse is sine. So we know that sine of angle B is opposite over hypotenuse. So we know that sine of angle B is equal to 4 over 10. So we know that angle B is equal to the inverse sine of 4 over 10. And so we get angle B is equal to, so let's go in our calculator, make sure it's in degrees mode, second function sine, brackets 4 divided by 10, close the brackets, we get 23.57, which is 24 degrees rounded to the nearest degree. 24 degrees. So we found, that our interior angles helps us to verify that that is the case. So far we have theta, which is really just angle A, we have angle B, and now what we need to find is our side A. So we can do that using a variety of techniques. We can use our Pythagorean theorem, we could use the trig ratios. So we'll find side A. Another way to name side A is you could have called it side BC. That's another way to do it if you don't have any vertices labeled. So side BC is the same thing as side A. You can call this over here side AC, side AB, like that as well. So for side A, let's use our Pythagorean theorem because we have some given sides for us. So we know that A squared plus B squared is equal to C squared. So we have the hypotenuse. We're looking for one of the missing sides here. So in reality, what we need to do is we need to do C squared minus one of the sides that we have. So B squared is equal to A squared. So we're doing this. So we're going to take our C squared, which is 10 squared, minus our other side there, 4 squared, is going to give us our missing side squared. I'm just going to carry the work over here. So that's going to be 100 minus 16 is equal to A squared. And then we're going to get 84 is equal to A squared. So 84 is equal to A squared. And so we know A is going to be square root of 84, which is going to be 9.17. 1.7 approximation centimeters. And if I asked you to round to one decimal place, you would say 9.2 centimeters. So we can go and fill that out here to 9.2 centimeters. So we solved the triangle. We found angle B, we found angle theta, we found side A. And so now that we have all the components found, we've successfully solved for the triangle. Make sure it's nice and organized. So you want to have a plan. You want to find every component of your plan. And then you've solved it fully. And then you go in and fill in the triangle as you complete it, because it's just a nice way to complete the puzzle. And the more pieces you have there, the easier it is to solve the problem. So let's go and start the next question, example 2. We're going to define a few terms and then work on the problem. We'll most likely be able to finish it in the next video. So we have a situation where it's more of a real-world application problem. So Mr. Efrate is standing at a window on the second floor of Loyola, about 7 meters off the ground. He is 1.5 meters tall. Mr. Efrate looks down and sees the students working on their math homework, but they need help. The angle of depression is 40 degrees. How far away are his students from the wall? So there's a term here that we haven't seen yet. It's called the angle of depression. So we'll define that, and I'll show you what that means. It's the angle between the horizontal or horizon and the line of sight when looking down at an object, hence depression down. So visually, what does that look like? Well, let's say, for example, that there's a person standing on a ledge over here, and that person is looking down. Well, there'd be the horizontal component here, the horizon there, and this is the line of sight looking down. So this is line of sight. This is the horizon or the horizontal. And this angle between that horizontal line and this line of sight, we'll call it theta for now, that would be your angle of depression. This is your angle of depression. Angle of depression. Right there. And so you can use the angle of depression to create these triangles to help you solve problems like this one over here. So let's start off by examining the situation and drawing what we would expect. So we're at on the second floor of Loyola. And here I am watching students, which is a bit weird that I'm watching you guys do math. So I'm looking down, you're in my line of sight. So there's a few students here doing math. Here's the horizon. The angle between that horizontal and this line of sight is our angle of depression, and it happens to be 40 degrees here. So 40 degrees. Now, we're asking you to find how far away the students are from the wall. So here's our wall, and that makes a 90-degree angle with our triangle here. And remember that I'm 1.5 meters tall. That will come into play. In the next video, we'll finish solving this problem.